Hi students, let us continue with the topic that is I/O interfacing of 8051 microcontroller. So now let us see the interfacing of input peripherals and interfacing of output peripherals in this video. So commonly used input peripherals. What are the commonly used input peripherals? Peripherals are nothing but external devices. The commonly used peripherals are dip switch, next push button keys, and then keyboards and analog to digital converters. So these are the commonly used input peripherals. So if you take, let us take this dip switch. How the dip switch will be interfacing to this interfacing I/O port that is connected to the dip switch. Now let us see. Interfacing dip switch. So let us take one of the dip switch. Here some of the registers that are there. RB7, RB6, RB5, RB4, RB3, RB2, RB1 and RB0. So these are the registers of port B. Okay, let us assume that the port B, it is an input acting as an input. Port B acts as an input output port. So let us take it as acting as an input port. So here we are connecting the dip switch to this port. So all should connect it to the ground, and we are giving the supply 10 kilovolts. This is the plus 5 volts. So this all will be connected to the plus 5 volts, and each resistor is a 10K. So this is a dip switch. Okay, so this dip switch is connected to the interfacing circuit of the input output port. So this is an input output port. Now we are connecting, now the port B acts as an input port. So this dip switch is connected to the I/O interfacing. So this completely is an I/O interfacing. So this interfacing will be connected to the microprocessor unit. So internally like this, the operation is like this. So this is a dip switch connected to the I/O interfacing. So here we are connecting to the input port in interfacing circuit, and that will be connected to the microprocessor unit to execute the operations. So here one side of switch is tied high. To a power supply. The power supply through a resistor. So this is a resistor that is 10K. We called it as pull-up resistor. Pull-up resistor. So the dip switch is connected with the help of this pull-up resistor. The other side should be connected to the ground. One side is connected to the pull-up resistors, and another side is connected to the, and this is one side. One side is connected to the pull-up resistors, and another side is connected to the ground. The other side is grounded. The logic level changes when the position is switched. So here the logic will be changed, whether it is a ground or it is a pull-up, that will be changed based on the position of the switches. And in the same way, the push button key is also the same as dip switch, except that contact in momentary. So this is the commonly used input peripherals. Now let us see the commonly used output peripherals. Let me write that. The next interfacing is the interfacing output peripherals. Interfacing output peripherals. So what are the commonly used peripherals, output peripherals? Commonly used output peripherals in embedded system or LEDs, 7-segment displays and LCDs. Okay, so these are the commonly used output peripherals. So let us discuss one interfacing of output peripherals, that is, let us take the 7-segment display interfacing. So let me write that 7-segment display interfacing of 8051 microcontroller. So in this interfacing of output peripherals, I am just taking this one of the example, that is a 7-segment display. So what are the features of this 7-segment display? This 7-segment display used to display BCD digit. The first point is it is used to display the BCD digits. So that is from 0 to 9. And next, a group of 7 LEDs will be placed. In 7-segment display, a group of 7 LEDs physically mounted in the shape of number 8. So these 7 LEDs will be physically mounted in the shape of 8, that is like this. So this is used to display BCD digits, a group of 7 LEDs, 1, 2, 3, 4, 5, 6, 7. So these are the LEDs, lights, 7 LEDs physically mounted in the shape of 8. This is look like 8. So here they are from A through G. So this is A, B, C, D, E, F, G. Okay. So this is a 7-segment display. So based on the operations that the output, the LED light will be glow. So whether it is 1 means these two will be active, all are off, and 2 means A, B, G, E, D, like that. Okay. Suppose 7 means A, B, C. These 3 will be on, rest of them is off. So whatever the input we are giving, this output, the LED light will be glow. Now let us see this. In this 7-segment display, there are 2 types of commonly we use here, anode and cathode. So with the help of the anode and cathode, the LED light can be glown in the 7-segment displays. So that is, we use 2 types, common anode, either we can use common anode or common cathode. So if we use a common anode, let us take, we have taken the common anode. In common anode, all anodes are connected together to a power supply. First is all anodes are connected together to a power supply. And next, cathodes are connected to data lines. Cathodes are connected to data lines. And in common anode, the logic 0 turns on a segment. So here you have to remember that logic 0 turns on a segment. So let us take this example. So here you are having, let me write this, a group of anodes are there. So let us take up to 8. So this will be connected to, this is DP, decimal pointer, G, F, E, and this is A. So A is nothing but D0, and here this is D4, D5, D6, and this is D7. The decimal point is D7. So here, to display digit 1, suppose I want to display digit 1, then all segments, here these are the segments A, B, C, D, E, F, G, H, these are all segments. All segments except B and C should be off. So except B and C should be off. Why B and C only? So this is A, B, C, D, E, F, G. So I want to represent, to display digit 1. 1 means this. So B and C should be on, and the remaining all the segments A, F, G, E, D should be off. Okay. So then here I am taking it as a logic 0. So logic 0 means only those segments that ought to be displayed, that should be 0, and the rest of them are all 1s. 1. So F9H. So we are giving the input as an F9H. Whenever I give an F9H, this 1 will be displayed on the screen. So this is a common anode. Let me take the common cathode. Let me write the common cathode. So if I take the common cathode, this should be reversed. Instead of 1s, I'll take it as a, I turn this as a logic 1. So in the common cathode, it will operate it as a logic 1. In the common anode, the system will be operated in logic 0. All cathodes are connected together to ground. So here all cathodes are connected together to ground, whereas in common anode, all anodes are connected together to a power supply, but here these cathodes are connected to a ground, and anodes are connected to data lines. And here logic 1 turns on segment. So whereas in common anode, logic 0 turns on segment, and here in common cathode, the logic 1 turns on segment. Now let us see the example for this. Here also I want to display digit 1. So I am taking the common cathode. So up to here, these are all connected to common cathode, and this will be turned to logic 0. This is the DP, G, F, A. So A indicates the D0, F, D0, D5, D6, and this is D7. So here if you want to display digit 1, all segments B and C except B and C should be off. So this is 7 segment A, B, C, D, E, F, G. So to display 1, except B and C, all should be off. So off means here if you are connected the system, all these diodes to common cathode, then it turns to this logic 1. The segment is turned to logic 1, turns on segment. So it represents like 0, 0, 0, 0, 1, 1, 0. You will get 0, 6. Okay. So when your system is connected to the common cathode, you have to give the input as a 0, 6, then 0, 6 hexadecimal. Then you will get the output as 1. Means the output light LED will be glown, B and C will be glown, these two segments will be glow, and all the rest of the segments will be off. So this is how these 7 segment display, the lights will be glown whatever the input we are given. So that will be based on the whatever the whether you are using common anode or common cathode, depends upon the that the light will be glow. Thank you.